Okay. So Jonathan's here to talk about the DPDK burst replay tool, which is a tool for DPDK testing, is it?
Yeah, to burst packets. Okay. So, hello everybody. My name is Jonathan Wibas, and I come from Marseille to present you today a tool I wrote named DPDK burst replay. We will talk about why I developed this tool, what can it do, how it works, and what are the future plane evolutions. But first slide on quick information on the tool. So it's a Linux command line tool. It uses a DPDK stack. It only needs two packages, DPDK and libnuma. It's open source, available on the DPDK Git repository. It's early stage, and it already have a big community of one developer, me. So, why I developed this tool? In fact, in my company, we want a way to burst real packets, real pcap file into DPDK ports to make some stress test and also functional test. And the two difficulties with the common TCP replay is that it uses the TCP IP stack of the kernel, and it can be struggled by the I/O of the hard disk drive. So we want a tool which is fast, so to bypass the Linux stack by using DPDK, and simple. We just have a tool of the TCP replay kind. So with this tool, we just have to specify the file you want to replay and the port you want to replay on. We also want the application to be scriptable, to be easily integrated into some Jenkins scripts or whatever. So, what it can do? First, it can load a pcap file. So pcap is a standard format for all the network dumps. We put all the packets in cache to be able to send it directly without reading them in the disk drive. And we can burst the packets on multiple ports, and we can replay the same trace several times in a row. And at the end, we put some statistic about how went the replays. And yeah, it abstracts DPDK stack, so you don't have to understand and to configure manually how you will put your DPDK setup. The goal is to have a simple tool. So, how to use it? There are two little prerequisites. The first is to have huge pages available. So huge pages is a standard Linux kernel mechanism to have a memory area shared between kernel and user space. With this example, you can create 4 pages of 1 gig. And after, you also have to bind the port you want to use into DPDK with IGB UIO, which is the DPDK driver. Then just call DPDK burst replay tool by specifying the file and the port. In this example, I want to replay the pcap on 4 ports, and we want to replay it 10,000 times. A quick word about its internal design. So let's say we have the tool linked with DPDK library and DPDK driver, and a pcap file which we want to replay on 4 ports. First, the tool preloads the pcap it will count all the packets and remind the biggest one. Why? To be able to calculate the needed mempool for DPDK to store the packets. So we initialize the DPDK, we create the mempool, and then we read again the file, and now this time we put all the packets in different caches, one per port. The idea is to avoid all lock contentions, context switching, just to be sure that there is no disturbing action between just sending the packets. After we initialize the port, set up maximum TX queues for the NICs. We spawn the threads. So in this example, 4, it can be just 1, it can be 10, whatever. Once everything is set up and ready, we replace all the pcap in the different ports. And at the end, we output some stats. On the terminal, it looks like this. And you can retrieve the 6 steps explained before. The preload, the allocation of the mempool, the NIC initialization, and at the end some stats. So per port, and at the end a total stats of bit rate, packet per sec, and send. Quick word about future evolution. So the goal is to fit a little more with TCP replay style. So adding option to play with the bit rate, to limit it, or to run a pcap respecting the timings. Maybe I have option to select multiple pcap to send on each port, or maybe to change them, or maybe run just one pcap, but throwing the packets on all the ports. Many things can be achieved. Other ideas is to create a Python module to be to integrate this application directly into a Python application. Another thing can be to add the config file to let the advanced users to be able to configure the internal parameters of DPDK initialization, kind of stuff. And most important part, it's you. So if you are interested, if you have some feedback, ideas, or contribution, please, you're welcome. And that's it. Thank you. Any question? Questions? Yeah. Yeah, in fact, it's not a generator. So we don't try a generator. We just want to take a pickup and we play it. Yeah, it's possible. Okay, but I don't know if it catch all the packets on memory or no. In fact, no. Yeah. Sorry.
You mentioned something like convention of the cache.
Yeah.
My theory is that you have those caches, and those caches are read-only for the threads, from what I think. So why are you saying there is contention? Jonathan, can you repeat the question for the camera, please?
Yeah. He was asking me why we create different caches to avoid some contentions.
Where is the contention?
In fact, when we send the packets to DPDK TX NQ burst, we give the packets to the DPDK stack, and we won't give the same packets to multiple threads, to multiple instances of, to multiple entrants. I'm not sure that it will work very well.
Okay, because the cache is made of buffers? Like buffers that you transfer?
Yeah, it's membuffs. Yeah. So,
I was just curious about the packet size variance, whether you were playing around with that initially, and was there a top constraint in packet size?
no constraints, can be jumbo frames or depends, but yeah.
Any more questions? Thank you, John.
Thank you.
So next we have